Hello, welcome to the Friday, August 18th, 2017 edition of the SANS and Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Jacksonville, Florida. It looks like the bad guys just don't run out of features to take advantage of in Microsoft's Office software. The latest feature is auto-updating links. You can link different documents with each other in Office. For example, a Word document in this case that includes an RTF document, and Office, or Word in this case, will automatically pull in that file in order to update the related content. Well, in this particular case, the attacker is using this trick in order to download a malicious RTF document that then has additional exploit code in it. This way, of course, they're avoiding some of the detection mechanisms that look for specific download techniques. In your web proxies, you may see these requests with a user agent of Microsoft Office protocol discovery. Now, this, of course, by itself doesn't mean it's malicious. This particular user agent is used for a bunch of different things, but take a look and see if you find anything interesting. And according to a paper published at Usenix by researchers from IBM, it looks like the Rowhammer attack is back, and this time for MLC NAND flash memory that's commonly found in SSD disks. Now, if you remember, the original Rowhammer attack affected RAM memory, and what it essentially did was that an attacker has access to a limited part of memory. The attacker can now flip bits very quickly within the memory the attacker has access to, and by doing so, due to interference with adjacent rows, the attacker can actually, in a somewhat controlled way, flip bits in other parts of memory that the attacker typically would not have access to. So apparently the same trick pretty much works with these MLC NAND flash chips and does affect solid state drives. An attacker essentially could now overwrite files that the attacker typically wouldn't have access to. This is something the operating system has no real control over because it's really a physical problem of this construction itself, and typically coincides with smaller and smaller feature size, where of course these individual features are no longer all that well isolated from each other. Now, with SSDs, of course, nothing is really all that straightforward. There's a lot of firmware interference here that determines how bytes are really written to the disk. For example, there's error correction that's happening, and also the bits are actually scrambled the way they are written back to memory in order to avoid some common errors that can happen. But nevertheless, this team was able to cause a couple of targeted errors. For example, they were able to flip an SUID bit on a binary that then allowed them to execute a binary that they deposited earlier via regular means as root. Now, unlike the attacks against DDR-RAM that Google originally came up with, in this case, there is actually something that you can do to prevent the attack, and that's to encrypt the disk. Once the disk is encrypted, then it becomes increasingly hard to impossible for an attacker to actually flip bits in a controlled manner. They may still be able to cause file system corruption, but they will no longer be able to flip bits the way this particular proof of concept did it. Well, it's Friday again, and I have with me another STI student, Nathaniel Quist. And why don't you introduce yourself?
Most certainly. My name is Nathaniel Quist. I typically go by the simple letter Q. I am a threat intelligence analyst with Logarithm Lab. Been here about 3 years, and Logarithm Labs is a SIM vendor, as many people know. I'm an SDI student. I'm finishing up my program. I've just finished my GSE written portion. Just passed that test yesterday, so now I'm getting ready to move into the actual in-person practical. So,
well, that's exciting with the GSE. Now, your paper that we sort of want to talk a little about was about active defense. That's, of course, a hot topic, active defense and deception. Well, active active defense is not about hacking back, or can you define a little bit active defense and what it really means?
Sure. I think that's a misconception that active defense is this attack the attacker's back. And I think as an industry, we've done a really good job of actually saying, no, we don't actually want to attack the attackers. It puts us in a, obviously a negative light, and puts us in susceptible to legal grounds for sure as well. But in my perception, what I feel active defense is actively taking a role in defending your network and not being so reactive if we can, but trying to be as proactive as possible. So that's kind of what my paper that I tried to talk about was, being proactive and not really, but keeping the attackers engaged in the environment and really trying to define and understand as much as you can from them.
Can you just mention one or two techniques that you talk about in your paper?
Well, certainly. So my paper is active defense using a labyrinth of deception. And the labyrinth is the kind of a tool that I'm working on. And it's really cross between, like, say, a honey net and a honeypot and a firewall. And it's kind of a mix of all these together. And what it is it really is a honey net in that it's an entire network that is, can be interacted and manipulated. And it's meant and designed in a way to be as real as possible. So it looks like a real environment. It'll have users, performing actions and moving files back and forth and making requests and DNS requests and looking as real as it possibly can. So when an attacker enters the environment, they don't have that, gut feeling, if you will, of them knowing they're in a honeypot. Keep that illusion as real as possible. So keep them going, keep them engaged, keep them deceived as long as we can. So the longer we keep them deceived, the longer we know what they're doing or what their tactics are and what procedures they use and what tools they use. And try to gain as much information as we can out of that. So when we are able to pull, say, malware out that we have acquired that they've dropped on the system, we can actively analyze that as they're still in the environment and then use those indicators of compromise and use that to actively defend against an attack that's happening.
Now, you mentioned honeypots, but what I have noticed over the last couple of years is that particular commercial vendors of tools like this avoid a little bit the term honeypot and really like to talk more about deception instead. And I think the distinction they're making there is that honeypots at least sound like honey pot that you attract something with. So you attract attackers, which of course most companies don't really want. They already have enough attackers attacking their network. Can you talk a little bit about how are these honeypots set up? Are they set up with specific vulnerabilities? Are they hardened? Or how do they compare to other systems in the network?
Well, I think it really kind of depends upon what your usage is of that honeypot. If you want to be an enticing target for an attacker just to be like, I'm just going to, looks like it's open and vulnerable, I'm going to start attacking it. It's good for some aspects because, you know that you're going to get, your system is vulnerable to compromises and it can just be readily exploited, and then you're going to get something in it. However, a savvy attacker may not believe that. They may be like, this is too good to be true, that, this isn't how a normal network is set up. It needs to be a little bit more defended, not quite so open and vulnerable. For malware analysis, it's great to have a completely honeypot that's open and just, readily exploited by everything, so that way you're ensured that you can actually have, you can actually make an exploit happen, and you can actually do your vulnerability analysis, your malware analysis on that system or that piece of malware that you're looking at. But for an attacker that you want to actually, I guess, entice to keep going and to deceive them, you don't want it to be, a Windows 7 in your DMZ. That doesn't make any sense. Why would you have a Windows 7 system or a Windows 98 system in your DMZ? It's really old, and it's not how systems work anymore, or networks, actively behave. So making it active enough, deceptive enough to where it makes it look current. It may not be vulnerable to every single, exploit that's available in Metasploit or anything like that, but it actually looks real enough that the attacker would want to spend a little bit of time compromising it.
So is there kind of a sweet spot where you get the best signal to noise? Like, I imagine if you have a system that's too vulnerable, you get too many attackers that you really don't care about. They're ways of script kiddies that wouldn't really be relevant at all for your actual infrastructure. Any tips here, sort of how to design this to sort of just get the right amount of attacks?
Sure. So my Labyrinth specifically is looking to be like your network. So say you were a client and you wanted to have this, Labyrinth in your environment, you would want that Labyrinth to be as real or as similar to your actual real network as you possibly could get it. So you would want it to be part of your, to look like it's part of your natural patching cycle, and it would be, fitting of how an IT department or an enterprise environment would actually patch and keep a system. Obviously we want somebody to exploit it, so maybe you happen to, you might patch like a month behind, or a month and a half, 2 months behind normal patching, or you might forget to patch, the latest Metasploit exploit that's in the environment. So, somebody that's attacking the system would be like, oh, it's still open. I can get in and compromise and see where I can go with it. So you still want to leave the doors open, but really you want to stay with industry trends. You want to stay with the latest patching cycle, but you might want to stay just a little bit behind it, just to keep it just a little bit open, so it still looks like you're actively maintaining it. You happen to be a little bit slower on your procedures, and then attackers would want to, what else can they get away with, or what else can they possibly, attack?
When you designed this network, one term I have often heard when it comes to deception is sort of the idea of deception stories. Did you have any stories in mind as to a story being the way an attacker is actually attacking a network, and then where you sort of set certain traps along the way? Any particular sort of events or so that you tried to model?
Honestly, I hadn't. I'm trying to stay away from that as much as possible. However, aside from, your normal network scanning, and then once you go to a scanning, you compromise the system. Once you compromise the system and grab credentials, you try to move out in lateral movement from there. Aside from like the kind of traditional attack life cycle that we prescribe to pen testing functions, I kind of wanted to leave it as blank story as possible. That way, you can have any actions that happen to the Labyrinth kind of speak for themselves. The kind of the beautiful thing about the Labyrinth is that if you as it's designed, everything that is in the Labyrinth right now is actually all monitored and known, and you put it there, so you know that it's actually what's going to happen inside of the Labyrinth. So as soon as something that's not prescribed is happening, you'll know fairly quickly that it's actually happening, and then you can follow that trend. So I'm trying to leave it as scriptedly unstoried as possible. I hope that makes a little bit of sense.
Any interesting hackers attacks that you were able to capture in your lab so far?
So the Labyrinth is, up to this point, has been very much proof of concept. So it's really just kind of what's plugged into my basement at the moment, and just standard drive-by scans, things like that. I have friends, hey, what's your IP address? Let me see if I can get into it. So the stories are really, I'm amazed on how often I'm actually scanned, just without being a broadcasted IP address. And I'm definitely scanned between the range of 1,500 to 3,000 scans a day, just happening across my IP address, just kind of being in that field of fire. So I've been very impressed with just firewall, technology in general. And then from that, the attackers themselves, so my friends that are, poking at the system and the IP address, really, if you are set up to see this much bandwidth, and this is kind of what you typically see, and then as soon as you start seeing someone kind of knock on the door, so to speak, really how perceptive it is to really see that relatively quickly. Again, it's a very quiet network, and I monitor it, and it's very small, so I don't have a lot of bandwidth that like enterprise networks would deal with at the moment. But yeah, it's kind of interesting to see how fast I can actually pick up on things.
Yeah, it actually sounds like you're matching sort of the average that we see with the Storm Center with our sensors. We typically call it survival time of about 5 minutes between sort of port scans.
Yeah.
And sounds like that's about the order of magnitude that you're getting.
No, it's actually pretty impressive. I was, I kind of heard, rumors to it, and I've been following Internet Storm Center obviously for a while. But actually seeing it in real life, it's nice to know that you actually monitor by how many minutes between attacks. I think that's something I hadn't looked at.
Any future plans with this?
Sure. So the next phase. So I'm getting a little bit. So now that the GSE is kind of cooling down and reverting more attention back into my Labyrinth again, and I'm going to start working on functionality of dynamic malware extraction, looking at primarily using volatility and using the functions that I use Zen server out of my systems right now. So being able to script the ability to strip that virtual machine's memory and then push that into my analysis tool, and then have a scripted volatility run through it and see this type of memory should be in this system normally, and can I identify processes that are not supposed to be running, registries that shouldn't have been targeted. See if I can actually start finding some of those, malware indicators of compromise on a dynamic basis as we're going through the Labyrinth. So that's my next major plan. Yeah.
Any ideas with client-side attacks, like setting up a mail server and just have a script that clicks on URLs or something like that?
That would be awesome. I have not started doing that specifically. I'm opening up little servers here and there, so I have a web server, obviously, and I have a little Active Directory server that stood up. When I have my friends come and poke on that, I just kind of, have those. But I would like to have a mail server. I would like to have my users, quote-unquote users in the Labyrinth, actually have email accounts and actually start actively clicking on some of those phishing emails and things like that to see, what pops on that. But I'd like to have that malware piece on the system first, so I can, actively get that information out of it as well.
Right. Yes. Well, thanks for joining me here, and hope that you're doing well in your GSE practical. That's it for today, and talk to you again on Monday. Bye.